What's up, everybody? Welcome back, and hi. Today we are going over our Unit 3 Test 2 review. Unit 3 Test 2 review. Wow, that came out smoothly. And this is all about trigonometry. So it's basically a trigonometry review. Before we move on to any of our slides, I just kind of want to review our three main trigonometry ratios, or trig ratios. So we have our sine ratio, which is opposite over our hypotenuse. We have our cosine ratio, which is adjacent over hypotenuse. And finally, we have our tangent ratio, which is opposite over adjacent. Awesome. Now, one thing, just as some of us may have heard before, to remember this, and a little mnemonic phrase, I mean something you could say to yourself to help you remember it, is so katoa. And how is that written out? SOHCAHTOA. Now, some of you may have heard your teacher say this. Some of you may have heard other people say it. Maybe you saw another video and they mentioned SOHCAHTOA. But the way this is and what it means is sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. SOHCAHTOA. It's an easy thing to remember. This is what I learned in high school in order to remember this. And it sticks with me to this day. Whenever I need to remember real quick, I'll just say, SOHCAHTOA. Boom. Got it. Right? So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So let's get into our first problem. Says an airplane is flying at an altitude of 2 miles above the level ground. The angle of depression from the plane to the foot of a tree is 15 degrees. Find the horizontal distance that the airplane must fly to be directly above the tree. So we have two angles here, and we know that they're 15 degrees. Up here, we want to find out what this x is. Well, one thing we could do is we can almost say, hey, this is like a rectangle. So if this is going to equal x, then down here is going to equal x. And the reason we want to do that is because now we have one triangle here. This bottom triangle, where we have a 15 degrees, we have a 2 mile distance up to our airplane, and we have x, which is our horizontal distance. So with that, what we're going to do next is label our sides. With 15 degrees is our reference angle. So 2 miles is going to be our opposite side. We could say that this angle B down here is our right angle, which means that this blue line is my hypotenuse. And last but not least, x is adjacent. So what do we have values for? We have values for our opposite, and we have a value of x for our adjacent, which means opposite and adjacent, I can't remember. Let's write out our SOHCAHTOA. Remember, SOHCAHTOA, right? And it's easier to write this than all of our trig ratios out. So opposite and adjacent, where do we have O and A? So, no. Ka, no. Toa, O and A. So that means we have to use our tangent, right? So we could write this as tangent of what's our angle measure? It's 15. So 15 degrees equals my opposite over adjacent. So 2 over x. Now, here's a quick tip just to save us some algebraic skills, right? And some steps that we have to do. When we have x in the denominator of a fraction and we want to solve for that x, the way it's going to work is we could swap places with this section here, right? But what does that mean? We could rewrite this as x equals 2 over the tangent of 15 degrees. They're going to swap places. Now, all we have to do is plug this into our calculator and we'll figure out what x is. Now, I keep saying this in all my videos, so if you've watched one of my videos, you already know this. But if you're new, then My favorite calculator to use on the computer, and I have an app for it. They have an app, is the Desmos Scientific Calculator. So I'm going to pull it up on half of the screen here. So this is our Desmos Scientific Calculator. And the reason I like it so much is because watch, when we type in our problem 2, and then our fraction really just means divided by, and then we're going to put tangent of 15. Look how it is written, just how we have it written here. So we know that we did it right. We could click enter, and our answer is right here. It gives me 7.464101615, right? So let's figure out where we need to round to. Does it tell us anything here? It says find the horizontal distance that the airplane must fly to be directly above the tree. It doesn't tell us, which means I'm going to round to the second decimal place, aka the hundredths place. So when we round off, it's going to give me about 7.46 miles. Nice warm up. Nice warm up. 7.46 miles. That is our horizontal distance here. We solved our problem. Awesome work. Next up, it's asking us, what is angle A to the nearest degree? So we want to figure out what is angle A. A is going to be our reference angle. So whenever you have a triangle, a right triangle, and you're missing a side or an angle, and you're given information like this where you have an angle that you're looking at and you have two sides that you're looking at, always go and label your sides, right? So opposite of A is 24. We can see that here's our right angle. Opposite of that is my hypotenuse, which means this last side here is my adjacent side. So once again, up top, I'm just going to write so, toa. Right, SOHCAHTOA. So what do we have values for? We have values for my opposite and hypotenuse. So if we look right here, OH, sine. So we could write this as sine, whoops, almost right, so sine of our angle A, which is our reference angle, equals my opposite, which is 24, over my hypotenuse, which is 51. Now we need to think to ourselves, well, this doesn't help me find A. It will get us there. The way we find A is by doing our inverse of sine, right? In order to get rid of sine here, we have to do the inverse. So we could rewrite this as sine inverse of sine A equals sine inverse, because what we do to one side, we have to do the other, of 24 over 51. On this side, sine inverse and sine cancel, and we're left with the measure of angle A equals. And on this side, we just plug into our calculator. So let me just drag it over again and show you how to get to your inverses, right? So this is what we want to type in, sine inverse of 24 over 51. In order to do that, you click on this little function button here, and now you'll see your sine inverse, cosine inverse, and tangent inverse. So you're going to click sine inverse, you'll click back to main, and all we have to do is type in 24 divided by 51. Boom, it shows up perfectly. Obviously, make sure we're in degrees, and we are good to go. So we have 28.0724864. But if we remember, it says to the nearest degree, right? We want to round it to the nearest degree. So we're just going to be left with 28 degrees for the measure of angle A. Awesome work. So we found a missing side. We found a missing angle. Really refreshing our brain and our memory here. Next up, it says, what is the value of the ratio of the length of the adjacent side to the length of the hypotenuse for a 45-degree angle? Round to the nearest thousandth. So the thing here is we don't really have to know any information about this triangle, right? Because it's telling us the ratio, adjacent side over the hypotenuse. So if we write out our SOHCAHTOA, which one has adjacent and hypotenuse in it? Not our sine, but our cosine does right here. Adjacent hypotenuse. So what we could do is, all it's asking us is what is the cosine of 45 degrees? That's what all this means. What is the ratio? Well, that's just our cosine. So we write cosine of 45 degrees equals, and we just plug it into our calculator. And I'm not going to pull it up on screen this time, but when we plug it into our calculator, it's going to give me 0.70710678812, right? And it goes on from there. But it asks us to round to the nearest thousandth. That's the third decimal place. So when we round this, we're going to get our answer to be 0.707. And that is our answer. We're good to go. It is that simple. They try to make this problem seem a little confusing. They give you a little bit of extra information here when you don't really need it. Moving on. Next one is another word problem. This one we're going to have to draw something. It says you're standing 40 feet away from a building. The angle of elevation from the ground to the top of the building is 57 degrees. What is the height of the building? So let's draw a little sketch. Now, I'm not the best artist, but I think we'll be able to put up with what I'm doing. So here's my building, right? Pretend like that's we'll redraw it. There, that's better. There's my building. Here's the ground. I'm standing somewhere over here, right? Hey, guys. Here, I'm a ginger, so let me color in some red hair. That's me. Don't mind my hair. It's a little messy. I haven't got a freshie in a while. And it says the angle of elevation from the ground, so the ground where I'm standing, the top of the building is 57 degrees. We also know about the 40 feet away. So we know that this is 40 feet. And last but not least, what do we want to find? We want to find the height of the building. So this distance here, which is going to be x. So what we notice is we have a right triangle here, right? The building and the ground make a 90-degree angle. So we have a right triangle. 57 is my reference angle, which means x is my opposite side. 40 is my adjacent side. If we write out our and we get in the habit of doing this, right? Write this out. Every single problem, just so it sticks in your brain and you have something to look at, right? Opposite, adjacent. Which one of these? Not sine. OH, that's not OA. AH, that's not OA. But tangent, OA, right here. TOA. So we write the tangent of our angle, which is 57 degrees, equals opposite over adjacent, so that's going to be x over 40. For this problem, we don't flip, right? We're not going to swap places with things. Instead, we just want to get rid of our 40 down at the bottom there by multiplying both sides by 40. I cancel on the right side, and I get, when I rewrite it, I could get x equals 40 tangent of 57 degrees. And this is something that we could just plug directly into the calculator. You type the 4, the 0, you click the tangent button, and you type in 5, 7, you click enter, and you have your answer, right? Once again, it doesn't tell us where to round here. So when we get our answer, and we plug this into a calculator, we get 61.59. And then what is our unit? It's right here. It is feet. Awesome. Let's keep it moving. All right. So next problem, we get the cosine of A equals 0.4. And it asks us, what is the length for the hypotenuse of AC? So the problem here is we can't really start finding this last question here of the hypotenuse because the cosine of A is adjacent over my hypotenuse, right? It has nothing to do with this 25, and we don't have any values there. So we can't do anything. Another problem that we come across here is we don't have two values. In a right triangle like we have here, you need two values to find a third one, right? We're only given one value. But we're also told that the cosine of A is 0.4, which is going to give us some information here, right? Why is that going to give me some information? Because we might not know any sides, but this can help us find the measure of A. So let's rewrite this. It says Whoops, sorry about that. The cosine of angle A equals 0.4. I'm just rewriting this line. If I want to find the measure of angle A, we could use our cosine inverse. I'm going to write cosine inverse of cosine A equals the cosine inverse of 0.4. On my left side, they cancel. I'm left with the measure of angle A. On my right side, we could plug that into a calculator. Now, a lot of times you see cosine inverse, and in the parentheses there is a fraction. Well, if you take those fractions and you divide them, it's going to give you a decimal just like we have here. So it really means the same thing, right? So let's go cosine inverse, plug it into a calculator of 0.4. So cosine inverse of 0.4, it gives me, and I'm going to round to our second decimal place here. So it's going to give me 66.42 degrees, right? And that's for this angle right here, 66.42 degrees. Now we have two pieces of information. We know that this side is my opposite side. If I want to find my hypotenuse of x, now we can do that. Opposite and hypotenuse is my sine ratio. We can say the sine of the angle we just found, 66.42, is equal to 25 opposite over x, my hypotenuse. Now, once again, our x is in the denominator. When we have it like this, we could switch, we flip, right? So we get x equals 25 over sine of 66.42. And that we could plug right into a calculator. So I'm going to do that. Remember, use the Desmo Scientific Calculator, like I showed you earlier in the video. We do 25, divide it by, we click the sine button, 66.42, we click enter, and we get the length. And once again, I'm going to round it to the second decimal place, so we get 27.28 meters. And that is our answer. That is the value of AC. We could even rewrite this as AC is equal to 27.28. Whoops, clicking buttons. 28 meters. There you go. Awesome, awesome work. Next up kind of makes us think of a relationship between complementary angles. So the very last lesson I taught, if you're not in my class, it's just a relationship between complementary angles in a triangle. So one thing we know is that in any right triangle, right, no matter what it looks like, let's say it looks like this. We have angle A, B, which is my right angle, and then C here, right? Pretend like that's a perfect right triangle. We know that A plus C is going to always equal 90 degrees, which means they're complementary, which means that we could flip and flop their sine and cosine. So the sine of A equals the cosine of C, and the sine of C equals the cosine of A. So that's one thing we know. Now, if we say that the measure of x is one of the angles, that means my other angle has to be 90 minus x, right? And then finally, if we say the sine of x is 1/3, we want to know which of these is also 1/3. So we could come on down to cosine of the angle, which is going to be d, 90 minus x. And it's that simple. They're trying to trick us here, though. They're trying to see if we know what complementary means, which 90 minus the angle measure, that means it's complementary. And then we want to know which are trig ratio, so it's going to be cosine. Next up is another problem where we have to think about, and we're going to use the same thought process, right? So let's read it. It says, in the right triangle ABC, the measure of angle B is not equal to measure of angle C. This just means it's not a 45, 45, 90 triangle. It says, let sine of B equal R, and let cosine of B equal S. What is sine of C minus cosine of C? Well, one thing we know, since these are complementary, since angle B plus angle C equals 90 degrees, we know that has to be true. It's a right triangle, so that has to be true. And since they're complementary, then we know that this has to be true also, that the sine of B is going to equal the cosine of C. And then the cosine of B equals the sine of C, right? So if we take our final equation here, the sine of C over cosine C, right? Let's rewrite it. Sine of C minus cosine of C. And let's start substituting what we know. Well, let me switch colors for this. What is the sine of C equal? Where else do we see that? We see it right here, sine of C. And it's going to equal the cosine of B. So I could rewrite this as cosine of B minus. And then, where do we see cosine of C? Well, that's right here. And that's equal to the sine of B. So let's swap it out and we write sine of B. And then, let's look up top. Where do we see cosine of B in our statement up here? The cosine of B is equal to S. So I'm going to swap this out for S minus, let me keep that as red, minus. And then where do we see sine of B? That's right up here. And that's equal to R. So we get S minus R. And that is our final answer, right? We just swapped out what we knew using information that we knew. Now, this seems a little complicated. If you don't understand exactly what I said, rewatch this section of the video. Trust me, you might not get it the first time, but if you rewatch it, you have a lot better of a chance of understanding it. Next up, we want to use the same idea here, right? That our sine and cosine of angles in the same triangle, so the two acute angles in the same triangle, that the sine and cosine swap, right? So what does that mean? For my first one here, right? Let's use green. We have sine of P, cosine of what? Right? So the sine of P is equal to the cosine of what? Well, we have to find what triangle P is in. And it's in this triangle right here. So the sine of P is going to equal the cosine of the other angle here, which is going to be V. And then my next one, the cosine of K is equal to the sine of what? Well, that's this triangle right here. So we have K, and then our other acute angles R. So the cosine of K is equal to the sine of R. All we have to know is that those two acute angles are complementary, which means that their sines and cosines flop or flip, and they're equal to each other. So once again, the sine of P is equal to the cosine of V, and the cosine of K is equal to the sine of R. Next problem. It says a submarine dives as shown in the diagram. So we have the beginning of the dive up here, and then the end of the dive. That submarine looks just about as good as I could draw one. That's not a good submarine. And it says to the nearest tenth, determine the dive angle whose measure is X. So the thing here is we have our X here. But what we can know is if we make this a rectangle like we did in one of the problems earlier, like that, we then know that this is 75 feet. And then this is 400 feet. So now we have values in the same triangle as my X value. And that also means that this is a right angle. It's the angle of a rectangle. So now we can find X. So if X is my reference angle, this means this is opposite, and this is my, not my hypotenuse, sorry. This is my adjacent. So what uses opposite and adjacent? Like we saw earlier, it is our tangent. So we're going to write the tangent of X, because that's what's missing, equals 75 over 400. And whenever we are trying to find that angle measure, it's a dead giveaway that we need to use our inverse, right, of whatever trig ratio we're using. Since we're using tangent, we need to say tangent inverse is equal to the tangent of x, which equals the tangent inverse, because you do it to one side, you got to do it to the other, of 75 over 400. Our tangent inverse and tangent cancel, and we're left with x is equal to, and then we just got to plug this into our calculator. So we're going to go click tangent inverse, 75, divided by 400. And once again, make sure you use the Desmos scientific calculator. So when we plug it in, and it says to the nearest degree we're rounding. So this is when we round it to the nearest degree, we get 11 degrees. There is my answer. Awesome. And our last problem. Last problem says, Mr. Stahl, haha, that's me, is on a camping trip, right? So I'm camping. Apparently this is a picture of me. No beard, right? This is what happens when I shave my beard. I go camping. So it says, Mr. Stahl's on a camping trip, and he wants to determine the height of a tree. Here's the tree. The tree is 50 feet away from Mr. Stahl. So let's label one of these lines. If it's 50 feet away, this line here is the distance from me to the tree. So I'm going to put a 50 right here. So it's 50 feet away, right? And then it says, Mr. Stahl's line of sight at the top of the tree creates a 35-degree angle, which we see here, there's 35. So I'm just going to rewrite this right here, 35 degrees. And then the angle of elevation, right? And then the line of sight for the base of the trees, 30-degree angle of depression, which is going to be right here, 30 degrees. And what it wants to know is the height of the tree. Well, our tree's cut into two parts here, right? This line cuts it into two parts, which creates two triangles, right? Something like this. Just like that. Now we know this distance is 50. So we're going to call this distance x and this distance y, which we're going to have to set up two things. We know that x, the height of the tree, is equal to x plus y. But we're going to come back to this when we find out what x and y is. So let's find out x and y. For our first one, our 35-degree angle, we're going to do that in one color. Up top, we'll say maroon. We know that this is my opposite, and this is adjacent. And then for my y, let's do that in blue. We know that this is opposite, and that this is adjacent. So same thing for both. So these problems are going to be very similar. So let's set up our 30-degree angle one first. So opposite and adjacent, that uses tangent. So God, toa. So we're going to say tangent of, we know our angle measure, it's 35, because we're doing the top one first, is equal to my opposite, which is x, over my adjacent, which is 50. So that's 1. We set it up. Let me switch colors. And for my bottom triangle, it's going to end up being basically the same thing. We're just swapping out that angle measure. So we're going to write tangent of 30 degrees is equal to, now it's y over 50. So these are basically the same problem, just with different angle measures. So we're going to do the same steps to both of them, but one we're going to find out x, we'll find out y for my other one, we'll be good to go. So for my first one, in order to get this x by itself, we multiply both sides by the denominator, which is 50, right? And that's going to give me x equals 50 tangent of 35 degrees, which we could plug right into our calculator. You type in 5, 0, click that tangent button, and then 3, 5. Now, don't type it in that way if you're using just your regular iPhone calculator. You could type it exactly like this if you're using the scientific Desmos calculator, which I recommend. If you do your iPhone calculator, that's on you, because I'm telling you that there's an app for this, right? All you have to do is go to your app store and type in Desmos Scientific, or if you're on your computer, go to desmos.com/scientific, or just Google it, right? and you'll be able to find it. And then if you use that one, you could type it in just like this. And you click enter, and it's going to give you an answer. Our first answer, and I'm going to round to the second decimal place, is going to give me x equals 35.01. And we found our value of x. Now, all we have to do is the same steps, but for our y equation here. Multiply both sides by 50, just like we did it the first time. And we get y equals 50 tangent of now 30 degrees. And when I plug this into my calculator, we get 50 tangent of 30 degrees. And we click enter. It's going to give me, and once again, I'm going to round to that second decimal place. So we're going to get y equals 28.87. But now, these aren't our answers. Remember, we have to plug it in to find the height of the triangle. Or, sorry, the height of the tree. So I'm going to put h equals, fill in my x, it's 35.01 plus 28.87. And finally, we just add these up in a calculator. 35.01 plus 28.87. Click enter. And we get the height of this tree is equal to 63.88. And last but not least, do we have a unit? We do right up here. It is feet. Box off our answer. We are good to go. And that was the end of our PowerPoint. That was the end of our practice problems for today. If you have any questions, please ask your teacher. Ask me in the comment section below if you need to. And just make sure you ask for help. People are here to help you as long as you ask for it. I hope you guys had a good time, or you learned a little bit of something today. And I'll see you all next time. Peace!